Okay.
Brad hasn't like banned you from asking questions yet.
We're recording, Tori.
Oh, sorry.
Okay. So just like the video we just watched, I'm going to draw up passive and active transport using different colors. Okay. So ignore this stuff. First step, we'll have our lipid bilayer. Our phospholipid bilayer, because these are phosphates, these lines are lipids. Okay. Then, okay. So first, we'll talk about this. So, like, we'll take for instance how I talked about earlier. If you drink tons and tons of sports drink, like Gatorade, so you have all this stuff floating around here, like so. Okay? So, because in our tissues and stuff, like say we have a high concentration of our sports drink in our body, and our body doesn't like that, so it wants water. So one of the ways active or passive transport happens is through osmosis. And osmosis doesn't need any help to go through the bilayer. It kind of just does its thing and fits right in, is in. So it doesn't need like amino acids or anything to help it get down into it. So that's osmosis. That usually happens with like water or like carbon dioxide. We'll just be able to fit through it. And then, no, sorry, I'm describing this wrong. This is diffusion. Diffusion doesn't need help. When something needs to get through, it could just fit through. It doesn't have to go through these guys. It could just squeeze through. Osmosis is, say we're dehydrated. So our body wants to put water from our tissues out of our cells. So it does that through osmosis. It just sends it on out and sends it in. Like say if we're drinking tons of water and we're dehydrated, our body will pull the water into our cells through osmosis. Okay, and then we have facilitated diffusion. And the way this works, so we have like glucose, we'll say that, sugar. Sugar right here. Sugar can't go through just normal diffusion. It has to have help. It has to have a help through a transport protein, which is these guys. So just like in the video, these guys help this glucose be able to come through and be able to come into our body. So those are our 3 steps for passive transfusion. And now I'll draw up active. Okay. These 3 steps right here that I showed you do not take any energy to do. Our body doesn't need to give up energy in order for it to go let's say in our cell, like we'll have our cell, yes. Okay, we'll have our cell in here, and we got like this little part in here, right here, that wants to get out. So this is called exocytosis. So a good way to remember that is it's exo, so it's like exiting. So what it will do is it'll, like in the video, it'll have this, and the cell was normally like this, but then it'll slowly kick it out. So now it's out. Okay, and then we got like another cell, and it wants to take a big chunk of something in. So that is called endocytosis. It's where it's going in, like entering. So it's got like this big chunk of whatever that can't fit in. So our body has to take energy, and what will happen, this will come over here, and it'll come up to this, and then this, the cell, will just kind of swallow it in, and now it's inside here, inside the cell. So that's exo and endo. Those are both active. And then we have active transport. So just like how we had phospholipid bilayer before, okay, so say we have a whole bunch of like these guys over here. And then we got like one guy here. So in order for this guy wants to be over here with these guys. Because it's not going in, it's coming out. So in order for it to come out here, it has to use energy. And the energy it uses is ATP. So, do you guys have any questions about what I've just taught?
No.
Okay, I think that's good.